An inflow and infiltration reduction study was completed in Basement Flooding Study Area 9 in 2015 and 2016 by the City of Toronto and Civica Infrastructure. The pilot project area is located in the Etobicoke-York district of the City of Toronto and consists of 557 properties, the majority of which are residential properties constructed in the mid to late 1950s. The objective of the project was to identify how extraneous rainwater and groundwater enters the sanitary sewers, to quantify the problem, and to then evaluate possible solutions that could reduce basement flooding. This extraneous flow is defined as inflow and infiltration, or I&I in municipal engineering. One of the significant findings of this study was the impact of residential foundation drain connections on the generation of I&I in a given catchment. A desktop review of all available foundation drain records for Area 9 indicates that the majority of residential foundation drains, also referred to as weeping tiles, are connected to the sanitary sewer system. This was standard practice in Etobicoke for homes constructed prior to 1962. Of the total 557 properties in the study area, 451 residential foundation drains were connected to the sanitary system. One sub-area in the northwest section of the study area, defined as 9 San 1, has a cluster of homes that does not match the same foundation connection practice of the rest of the study area. In sub-area 9 San 1, homes have a separate service lateral that directs water from foundation drains to the municipal storm sewer. An extensive field investigation, including monitoring of rain and sewer flow levels, groundwater levels, smoke and dye testing, and visual sewer inspections during rainfall, was conducted in order to validate the desktop results and to rule out other sources of I&I. The flow monitoring program, which had 8 flow monitors distributed over the 45-hectare area, measured chronic levels of I&I in all but one sub-area. As expected, sub-area 9 San 1, where homes have their foundation drains connected to the storm sewer, showed significantly less I&I in all rainfall events. Smoke and dye testing of the entire study area, which included a detailed inventory of each drainage feature, identified other minor defects that could only account for a fraction of the measured I&I. These defects included residential downspouts, clean-out caps, basement walkout drains, and window wells. All traditional field inspection and record data indicated that the residential foundation drains were the major factor in the chronic historical flooding experienced in this area due to the amount of water they contribute to the sanitary sewer during wet weather. To further validate these results, additional CCTV pipe inspections were commissioned to visually capture the foundation drains in action during wet weather. Inspections were completed on 2 dates: October 28, 2015, and August 16, 2016. The October 28th event had 53.1 millimeters of rain over 17 hours, while the August 16th event had 15.5 millimeters of rain over 12 hours. The October 28, 2015 CCTV pipe inspection completed in the sanitary sewer indicated that the sewer pipes were in good condition under wet weather conditions, with no significant contributions noted from pipe defects. However, significant amounts of clear water were observed coming in from the sanitary service laterals. These service laterals corresponded to homes where records show foundation drains were connected to the sanitary sewer system. Using the results from the October 28th investigation to pinpoint problem areas, a second CCTV pipe inspection was completed on August 16, 2016. This time with a focus on the sanitary service laterals from the houses to the street. The intent of these inspections was to distinguish between I&I contributions from possible defects in the service lateral pipes and water coming from the foundation drains. This was completed through the use of a CCTV camera with a lateral launch camera, a robotic device that is able to launch a secondary camera from the main sanitary sewer into the home sewer lateral. Assuming that the lateral is clear, this allows the camera to inspect up to the house's foundation and verify the source of water. At a property in Area 9, where the lot surface drainage pattern is typical of most residential settings in Toronto, dyed water was poured on the ground surface to replicate water flowing from the neighbor's downspout. The water was poured at a rate less than the approximate 3 liters per second expected during a significant rainfall event. It is important to note that dye testing was completed during a sizable rainfall event to reflect the saturated soil conditions that would exist during a storm causing basement flooding. The time it took for the dyed water to percolate through the backfill material adjacent to the foundation wall was the most startling finding. It only took 10 minutes for the water to get from the ground surface into the foundation drain, through the sanitary lateral, and into the sanitary sewer. The observed flow rate during this test is also similar to what was observed during the October 28, 2015 event. In total, 4 homes were tested this way, and they all responded within 10 minutes. Given the density of foundation drains connected in the study area, the fast response of these foundation drains is considered the significant contributor to the basement flooding problems in this area. Field inspections identified poor lot grading at a number of properties in Area 9, which can further amplify this issue by encouraging rainwater to infiltrate near the home and reach the foundation drain. Using the findings of the field inspection program, a sophisticated numerical model was created using the InfoWorks ICM software to determine the possible benefits of disconnecting the foundation drains. In Area 9, it was determined that the reduction of I&I impacts resulting from the remediation of typical engineered I&I defects, such as downspouts and maintenance hole pick holes, will only reduce peak flows by 5%. This limited reduction will not enable the city to achieve the targeted level of protection against sanitary sewer backup in the study area. In addition to removing all I&I contributions from downspouts and manhole pick holes, an 80% reduction of I&I flow generated by foundation drains in the study area would also be necessary to achieve the targeted level of protection. This would require disconnecting the foundation drains of 361 homes from the sanitary sewer system. This constitutes 65% of the 557 homes in Area 9. It has been demonstrated in Area 9 that foundation drains respond rapidly to rainfall and are the primary source of I&I in the study area's sanitary sewer system. This quick response contributes to high flows in the sanitary sewer, which leads to basement flooding. Reducing the I&I contribution from foundation drains will significantly reduce the risk of basement flooding from sanitary sewer backups. Furthermore, reducing the amount of rainwater currently draining to the sanitary sewer through foundation drains will reduce environmental spills as well as operation and maintenance costs at pumping stations and treatment plants.